information updated. Is it clear? Yes or no?
Yes.
Where this metadata is stored?
It will be up to 4 SSTs. Up to 4 SST. The first 4 SST, and every SST there will be 15 GB per SST. Okay, if you are using old version, 30 GB, but only on first 2 SST. But now we have 4 SST and 15 GB. In that case, we are getting 60 GB overall per node to store the metadata.
If suppose we have a hybrid cluster, a hybrid node, so the disk is a HDD, so HDD also have the same
It will
concept.
be SST only. Yeah, it will be only SST.
Mean to say we require 4
The first
additional.
2 SST. The 4, no, maximum 4 SST.
First
In
2
case
SST.
of hybrid, we are first 2 SST. In case of hybrid system, it is going to be first 2 SST.
Okay, where the means ops log and the
Yeah,
read
right.
source.
Yes.
Okay.
Yeah,
Okay.
yeah. Okay. So in case of RF2, this is again going to be 3 copies. In case of RF3, it's going to be 5 copies. Okay. So now coming back to metadata, we have 2 types of metadata. One is local metadata, and then other one is global metadata.
Sorry to interrupt you. If the 5 copies are there, so we require 5 SSD.
No, within a cluster.
Within the cluster, each node have enough.
It is not about number of, like, when I say 4 SSD, 4 copies, it doesn't mean that. Okay, so let's take here. I'm storing some data here. This is my VM. That VM stores some data here. That information updated in the local metadata now, right? This metadata will be replicated to 3 different nodes. Likewise, this maintains its local metadata. That metadata replicated to 3 different nodes. Got it?
Okay, and 3 different node have enough for these are 4 SSD for.
So if one node goes down, if one node goes down, still till this metadata is already replicated to 3 different nodes. Sorry, 2 different nodes. I mean, yeah, so overall 3 copies, right? 2 different nodes. So we have a metadata is protected to tolerate the failure.
Each node have a reserve for 4 SSD, first 4 SSD, each node.
Yeah, yes, each node you have a first 4 SSD, and every
Oh.
node you will be having 15 GB. So overall you get 60 GB per node.
Okay. Okay, thank you.
Okay, so now we have 2 types of metadata: local metadata and global metadata. So local metadata contains more detailed information about which disk, which sector, which extent. It contains more local, specific local information. Global metadata will contain about the node information. Let me tell you here. So let's take the node. Okay, in every node. So here we have a local metadata. Here we have a local metadata. Here we have a local metadata. So this local metadata will contain this more detailed information, like let's take example of library. So library, they maintain a inventory, right? Yes or no?
Yes.
If you need certain book, let's take, you want to read Nutanix Bible. It's a book. You want to read it. First, what you do, you go to library and you will look for the library metadata, I mean, which is library index. You will see whether the book is there or not. Right? You don't go and check each rack by rack to check whether the book is there or not. Instead, what you do? Now everything is systematic. You just give the name of the book. They will tell you whether the book is there or not. Yes or no? Yes, did you understand what I'm trying to say? So let's take, let's take Nutanix Bible is a book for an example. In the book, you want to read something about reduplication. So now you are going to library. Let's take, this is something like you want a hard copy to read it. You are going to a library and the moment you reach library, you ask the librarian, you ask them whether this book is there or not. So let's take if the library is 4 floors. In every floor, they have 1 lakh books, so totally 4 lakh books. Okay, so it would be very definitely it would be very difficult for you to go and check book by book, floor by floor. So instead, what you do, you ask librarian help and you tell him that I need this book. He will immediately check in his database and tell you whether the book is there or not. If the book is there, what information he provide?
Go for
If
this
book
floor.
is there, yeah,
Go
floor number.
And rack
Floor
number.
number, rack number he gives. Correct? This is like in Nutanix, like node number. Okay, this is node number, like this is a global metadata. So once you get the rack number, but end of the day, what you want to check? You want to check the deduplication. Doing that, first you go to library and you get this information. So getting this information is a global information. Like globally, the library has this book or not. It tells you where the book is and which rack it tells you, but it doesn't tell you, page number of the book. Correct? I want to read the deduplication. The librarian will not be able to help you. Hey, go to this floor number, go to this rack number, go to this page number, you can get this information. He can't give that information. What he can provide, he can only give you the floor number and rack number. So once you go to the floor number, rack number, you take the book. Now you refer local index to check the page number. Yes or no?
Yes.
The same thing here. The global metadata contains where the data is, where the book is, on which floor, which rack, right? Likewise here, where the data is, whether it's a local node or in a remote node. It tells the remote node, this is the CVM IP, go and talk to that CVM. Go to the rack, go to that CVM, okay? So once I reach the rack, then I'll take the book, I'll refer the local metadata. Likewise, when I reach the remote node, I take the local metadata to check on which disk the data is. Okay, this extent or sector is local metadata. Is that clear?
Yeah.
Everyone?
Yes, sir.
Sharan, Ajay, Sai, Sandeep.
Yes.
Yes.
Okay. So overall, there are 2 metadata. One is local metadata and global metadata. So the local metadata is something like a book indexing. Global metadata is something like a library indexing. So if I'm not sure whether the book is there or not, I'll ask the librarian help. Likewise, if I'm not sure about the data, where the data is, I'll ask my global metadata. It tells, hey, go to node number 5. That node has this data. Then I'll directly go to node 5 and then I'll ask, I need to get local metadata information about on which sector the data is. For that, I'll take the help of local metadata. All good, right?
Yes, sir.
Yeah.
Okay.
So one question, like let's suppose we have replication factors, right? We are making copies of the data. So each
Yeah.
node will make index of their own local data, right? Mean to say
Yeah.
like their copies as well.
Yeah.
So how primary data is getting marked? Like this is the primary location, this is secondary, or this is your third. Yeah.
Okay. So if a VM running here, that's going to be a local to this node. So the
Yeah.
condition is always data local. So the default behavior is data local. So it always look for the local metadata table first. If the local metadata doesn't have that information, then only it will go for the global metadata. So now global metadata tells, okay, this data you're looking, okay, that's in the node 3. So now this request, this VM or this CVM, you have a CVM, that CVM send this request to the remote CVM. Now remote CVM, that it needs to validate its local metadata table, because this CVM needs some information, but this CVM doesn't know which disk, which sector the data is stored on the remote server, but it only knows the global information, which is the node name and CVM name. So it comes to this CVM. Now this CVM will check local metadata to double check, to verify whether the data is there or not. So local tables tells, yes, this is data is already in your system. Okay. So now this data will be shared to this CVM. Okay. So now this is going to be a remote read. So remote read is not permitted in the system. So immediately this data will be migrated to this local node to keep the data local. So Nutanix will maximum 99% will try to keep the data local. Even if you have a remote data, immediately the data will be migrated to the local node.
Got it. Thanks.
So the default preference always going to be local metadata. Okay.
Yes.
Okay. So next, there is a concept for Cassandra, there is a concept called ring. So Cassandra maintains a ring, like if you have 4 nodes or 5 nodes, every node will be gets added into Cassandra, rings. Cassandra ring. Okay, so in case if you are doing an expansion, the cluster node need to be added into the Cassandra ring so that the metadata, everything will be fetched properly. Okay, so the node status, we have a different status for, Cassandra ring. So one is normal, second one is forwarding, second one is detached. So all normal means all good. Okay, forwarding means data is being moved to other nodes due to node removal activity. If you are going to remove a node, this node will have some local metadata and global metadata that needs to be migrated to the other node. So data will be moving from one node to other node. If that is happening, you will be seeing the ring status as forwarding. When you say detach, it could be a failure of the node. So if the node has some failure, it can be anything. If the node is not working as per the standard, then the node will be detached from the ring and it cannot be a cluster. It cannot participate in cluster nodes. So you need to add this node back to the ring that you need to run some command. But to check the Cassandra ring information, there is a command called node tool -hide 0 ring. So this will tell you how many nodes you have and what is the status of those nodes. So if you want to know what is the current, like I said, right, there are 3 nodes, Zookeeper nodes, and 5 nodes are RF3. So I want to see the ring status of all the nodes. Then you run this command, we will get the status of the Cassandra ring. It can be normal, forwarding, detach. This you may need to run, in your administration side. Sometime, we see this, you may need to run this command to double check what is the Cassandra status node. Okay, so when the node will be detached, when the node will be taken out of the Cassandra ring and put it into forwarding mode if any of the following condition match. If the node is completely down for 30 minutes. Okay, if the node is down for 30 minutes, then database will be forwarding, the ring status will be forwarding state because it will start forwarding the information. Okay, or 7 flaps in 15 minutes. what I'm trying to say, if Cassandra restart 7 times in 15 minutes. Okay, these are the conditions, and node can go into the from detached to forwarding state. But to check the latest status, run this node to -type 0 ring. Got it or no?
Yeah. So Cassandra runs on every node, right?
Yeah,
Every node in
Cassandra
the
status
cluster.
will be yes. The database will be stored on 3 node in case of RF2 and 5 node in case of RF3. Like, we have a zookeeper monitor, like here, the Cassandra, every node will be part of the, Cassandra thing. All good?
Yeah.
Okay. So I think the Stargate over Cassandra will be over Genesis over Acropolis over. And then there is one important service which I haven't included here, but that is also important. There's a service called Curator. What is Curator?
I heard about some
Any idea?
service with Medusa as well.
Medusa is like an interface to the Cassandra. Like Zookeeper, we have Zeus. For Cassandra, we have Medusa. And that's a small database which also serves the catching. So when you talk about, I think yesterday you asked me this question. Catching will be at many levels. Like you have a configuration data, you have a metadata, you have a guest stream data. So for all three, we may have a catching data. So metadata catching will be maintained by Medusa. Medusa is an interface to Cassandra, and it also a small database which maintains the cache. Okay. Next, Curator. What is Curator?
Map reducer.
MapReduce. What is MapReduce?
Deletion of the old data or the data which is not required.
Type of a scrubbing type of a thing to be done by the curator.
Provide removes the unnecessary data, old data.
In the storage terminology, it's called scrubbing. There is some backend where the data is scrubbed in the hard drive.
Okay. So here we have first to SSD. And these are hard disks. So I said the read and write will be maximum. It will be done from the SSD because SSD can make more performance. So your data will be, in terms of read, your data will be moved to here. If the data is not accessible by any VM, then it will be written back to the capacity tier. So this is a performance tier. This is a capacity tier. So in terms of read and write, most of the data will happen at this disk level. So there is a dedicated space given for the hard tier. So this is a performance tier or hard tier. This is capacity tier or cold tier. Okay, system will move the data from hot tier to cold tier or cold tier to hot tier. This is an automatic behavior. Okay, so if I read the data from SSD, I can make for an example, if I can make 1 lakh IOPS, 1 lakh input output per second. So from hard disk, probably I can make 500 IOPS. So SSD give me more performance. So I try to keep the data in the SSD so that VM can quickly read the data, quickly write the data. Okay. In terms of read, so the data, most of the read will be served from the SSD. And then if the data is not accessible by VM, then it will roll back, return back to the capacitor so that it can make the free space for new data. If it keeps the data permanent here, other data cannot be stored because it's a small space. that movement, hot tire to cold tire movement, or cold tire to hot tire movement is map reduce feature. Okay, this happened using curator because somebody need to tell which is hot data, which is cold data, correct? That responsibility is curator. Curator has map reduce feature. That map reduce will do this hot tire to cold tire movement. Okay, is that clear?
Yeah.
So next, curator runs on every node. Then curator checks every disk in the node and cluster. Here, curator runs on every node and it checks every disk. So in every disk, we have a small space reserved for curator. Why this need to sit in every disk? Because curator only check a lot of information about the data. Okay, let's take a scenario. My VM is running here. It is writing some data here. Next, what will happen? Next, what will happen?
It will make a copy.
Yeah, it will make a remote copy. So now, curator responsibility to make sure that 2 copies are created. In case if the second copy got corrupted or anything, curator will take this copy to repair this corrupted copy. Okay, so how come curator come to know whether the data is corrupted or the data is missing of 1 copy? So I need to create 1 copy. How the curator will get to know that? So there are 2 scans. One is full scan, and then other one is partial scan. So the scanning information you can find in the, I sometime back I said, right, you can change the port number and you can find the information. So there is a port number for, I think, I forgot the number. So there is a port number available for curator. If you provide this information, you get when the last full scan happened, when the partial scan happened, what is the status of the, each scan, you can get the report that you can